Welcome to this deep dive on Amazon Bedrock AgentCore identity. Your agent needs to access users' data from external services, maybe their Google Calendar, their Salesforce contacts, or their GitHub repositories. But here's a challenge. Those APIs require the user's explicit consent. The user has to say, yes, I allow this agent to access my data. So how does your agent get that consent? And then use it to access the APIs without ever seeing the user's credentials. In this video, we will see how AgentCore Identity orchestrates the OAuth Authorization Code flow, letting your agent act on behalf of users without exposing sensitive credentials to your code. We will answer the question, how does your agent act on behalf of your user, in two parts. First is establish. Before runtime, you register your app with the identity provider and configure AgentCore to handle the OAuth flow. You set up the credential provider, store the credentials securely, and register the callback URLs. Second is delegate. At runtime, the user grants consent through the identity provider, and AgentCore securely delivers the tokens to your agent. Your app verifies the user, AgentCore exchanges the code for tokens, and your agent gets what it needs to access the user's data. As a developer, you first create a credential provider. Your agent needs tokens to access user data from external services like Google, but it should not have access to the OAuth secrets used to get them. The credential provider stores your client ID and secret securely in AWS Secrets Manager. Your agent never sees these credentials. Next, write your agent code. Look at Get User Calendar. It's just a simple function that calls the Google Calendar API with an access token. That's all your code needs to do. The requires access token decorator handles everything else. It tells AgentCore, use this provider, request these scopes, and when the user needs to grant consent, call this function to send them the authorization URL. Before your function runs, AgentCore gets the user's consent, exchanges a code for a token, and injects it into the access token parameter. Your agent gets a valid token without writing any OAuth logic. And finally, deploy your agent, and you're ready with an agent that can access user data on their behalf. So that's what you do as a developer. 3 simple steps. But what does AgentCore do for you? From here on, we are going to go behind the scenes. Everything you're about to see is handled automatically by AgentCore. You don't need to build or manage any of this yourself. You created a credential provider in AgentCore Identity by giving it your OAuth client ID and secret from the external identity provider. This can be Google, Microsoft, GitHub, whatever you are integrating with. AgentCore stores that client secret securely in AWS Secrets Manager. Your AgentCore will never see it. You get back the provider ARN and a callback URL. You register this URL with your identity provider as the allowed redirect URL, not your app's URL, AgentCore's URL. Why? Because when the user grants consent, your identity provider sends back an authorization code. You want AgentCore to receive that code and exchange it for tokens, and thereby keep that step out of your agent's code. When you deployed your agent, AgentCore Runtime created a workload identity for your agent in the AgentCore Identity Service. This workload identity is how your agent will prove who it is when it asks the identity service to retrieve credentials and tokens. It's stored in the identity directory and associated with your deployed agent. That completes the establish phase. Your credentials are stored securely and your agent has an identity. Now let's see what happens at runtime when an agent needs to prove who it is to access the external service. A client can now invoke our agent. This could be using IAM or OAuth authentication, but we won't go into those details here. Once the client is authenticated, AgentCore Runtime gets a workload token for this agent. AgentCore Runtime then invokes the agent container, passing the workload token in the header. This token is agent's proof of identity. It will use this to request an OAuth bearer token when it needs to call external APIs. Let's look back at the code the developer wrote. The requires access token decorator specifies a credential provider name and sets a OAuth flow to user federation. When the get user calendar is called, the decorator is triggered. Let's see what happens behind the scenes. Your agent code hits the requires access token decorator, which calls get resource OAuth2 token with the workload token and user federation flow. The identity service does not return a token yet. It can't, because a user hasn't consented. Instead, it returns two things: an authorization URL, which is your identity provider's login page with all the OAuth parameters baked in, and a session URI, which is a unique identifier for this specific auth flow. Your agent uses the on auth URL callback to send that authorization URL to the user. How you do that is up to you: streaming response, WebSocket, email, whatever fits your app. Your user clicks the link and opens their browser. They are taken to the identity provider's login page where they are asked to ask their credentials. Your agent never sees those credentials. The identity provider now asks whether the user consents to the agent accessing their data. The user says yes. And now here's where it gets interesting. The identity provider redirects to the callback URL that was registered. And remember, that's AgentCore's callback, not your app's. The identity provider sends the authorization code and state to AgentCore. This is the first hop. Now, why an authorization code and not the token itself? For security. The code is short-lived and useless on its own. It can only be exchanged for tokens using the client secret. And that exchange happens server to server, not through the browser. AgentCore has the secret, so AgentCore does the exchange. AgentCore receives the authorization code and stores it temporarily, associated with the session ID, but it does not exchange the code for tokens yet. Instead, AgentCore redirects to your application's callback URL with the session URI in the query parameters. This is a second hop. Why your app? Because your app needs to verify that the user who just granted consent is the same user who started this flow. Only your app knows who's currently logged in. Your application callback receives a redirect with session URI. Your app validates the user session and calls complete resource token auth with the session URI and the user identifier. Why this call? It's a signal to AgentCore that your app has verified the user. Without it, AgentCore won't exchange the code for tokens. Once AgentCore receives this confirmation, it retrieves the client credentials from Secrets Manager, calls the identity provider's token endpoint, and gets back the access token and refresh token. AgentCore stores these tokens in token vault associated with the specific user and workload, and your app gets a success response. The requires access token decorator was waiting for the user to complete authorization. Now that your app has called complete resource token auth and the tokens are in the vault, this decorator retrieves the access token and injects it into the function's access token parameter. This token represents the user, not the agent, not the application. The user who logged in and granted consent. The agent can now call the external API on behalf of that specific user. Now the agent function executes. It calls the external API, Google Calendar, Salesforce, or others, with a user's access token in the authorization header. The API validates the token and returns the user's data. The agent is acting on behalf of the user who granted consent and not on its own. The agent now processes the user's data and returns a response back to the client. That's a complete authorization code flow, from user consent to API access, with AgentCore handling the OAuth complexity and your app verifying the user identity. Thanks for watching this video. Check out the Amazon Bedrock AgentCore documentation to get started. Happy building.